Okay, pause your video and write this down. Now, some more tools to deal with series that may have negative terms. If the series has only positive terms, then we use 11.3, 11.4. But now we're moving on from those series. Okay, let's look at this example here. So what is AN? AN is the -1 to the n over n squared. So the absolute value of AN is, I'll just copy it out. But what happens is that minus the alternating part just disappears, right? The alternating part is going +1, +1, can just be always +1, right? So summation of the absolute values is just summation 1 over n squared, which is convergent, right? Is convergent going back to our p-test, since p is equal to 2, which is bigger than 1. So we say the original series is absolutely convergent. So that's my little short form. I'll put it up here, AC. Okay, so if it's absolutely convergent, does that mean it's convergent? And the answer is yes. Okay, very simply, A, C implies C. Absolute convergence implies convergence. And you can give a little proof here. You assume summation AN is absolutely convergent. Proof is convergent. I'll do a trick here. It's clever. Actually, I go AN plus the absolute value of AN. So if you take a number 2 plus, -2 plus the absolute value of -2, you can see that that's always bigger than 0, right? But it's less than absolute value of -2 plus absolute value of -2, right? And that's 2 times absolute value. And so what do we have here? Well, we're going to use a comparison test using this inequality. Summation 2 absolute value is convergent. This is my assumption that I made at the beginning. Well, very close to the assumption. This one. So summation AN plus absolute value of AN is convergent 2. So, okay, summation an plus absolute value of an minus the summation of absolute value an this is a technical trick here. Okay, we established, so this is convergent. So here we have a convergent minus a convergent. So it's convergent. And then because we have convergent series, we can add the summands, or in this case, subtract the summands. If you have a series absolute convergent, I arrive at the series must also be convergent. Okay, convergence implies convergence. What about -1 to the n over just n? The absolute value of an is just 1 over n. So summation absolute value of an is equal to the harmonic series is divergent. Okay, where are we now? This is convergent by alternating series test. But this guy is divergent. So my conclusion here is not absolutely convergent. Okay, let's recap. Hazy have a series is convergent. Alternating series. But it turns out that the series of absolute values is divergent. Okay, original series is convergent, but when I take absolute values, it becomes divergent. This is not absolutely convergent. We have another name for this. So definition. If the series is convergent, but the series of absolute values is divergent, then summation n is said to be conditionally convergent. CC. Okay, what else here? See the big fat diagram. Let's call this the Venn diagram. It's called. So all series. Let's say this box is all. Let's write series nicely. No, I like this diagram. Let's say, do like this. So let's say divergent series right here. Let's say this is convergent series. So every series is either divergent or convergent. Now, within the convergent series, use a different color here. You have a division. They are either absolutely convergent or conditionally convergent. So what can I say? Every series is either divergent, absolutely convergent, or conditionally convergent. That's a pretty ugly diagram. I can do this another way. Yeah. All series either fall into two categories, divergent or convergent. And inside of convergent, you are either convergent or you are absolutely